Yes. So class, what's your name? Who is this? iPad CO3. What's your name?
Ma'am, my name is Mithun Martin.
Method.
Yeah, ma'am.
All right. And the next person, Pavitra.
Yes, Pavitra.
Pavitra. All right. Fine. See, in today's class, we'll begin with this lesson, chapter number 3, that is current electricity. Before we begin that lesson, I want to ask you, Mithun, just tell me what's the current physics lesson going in your school? How many chapters have completed before vacations, or what is current chapter going in physics in your school?
Ma'am, actually, first 5 chapters are over, and right now it's vacation.
First chapter is over, chapter number 1.
Yeah.
All right. So when the vacations will get over, you will start with electric potential and capacitance.
No, ma'am. First 5 chapters are over.
Okay, first 5 chapters are over. All right. Then you'll begin with EMI most probably.
Yeah, after the vacation.
After the vacations. And what about you, Pavitra?
We were doing moving charges.
Moving charges and magnetism. Means chapter number 4.
Yeah, we were doing that. Then
All right.
vacation.
Okay, then the vacations have started, and after that you will be continuing with the chapter number 5. All right, both of you. That's what I wanted to ask. See, in today's batch, what we'll do from today's class, in this batch, we'll begin with current electricity. So many students of your batch have had the introductory class where we had discussed the basic topic like electric current. So we'll continue with that today. Aman, is this audible to you? Aman?
Yes, ma'am, it is.
How do you pronounce your name? It's Ayman or Aman?
Either way, ma'am.
Fine. It's either way, then it's fine. So, Aman, we had this class with you, but for the 2 students, they are, so I'll be just giving them introductory. So just wait for 5 to 10 minutes.
Okay, ma'am, no problem.
This class will not start at this time because a half an hour got delayed today. Otherwise, whatever usual time you people have, it will be starting from that time only. So regarding the backup of the previous lessons, like whatever we had, chapter number 1 is there, chapter number 2 is there, this is chapter number 3, current electricity. So you people will be requiring the backup of few topics which are very, very important. Like if we talk about that topic, that is your Gauss theorem from your chapter number 1. So Gauss theorem is such an important topic that every numerical from the lesson do come from that topic. So what we'll do one thing on Fridays or on any day which is mutually decided by all of you. We'll discuss that day in the class. I'll provide you the lecture for it. Recorded lecture we had many batches, so we had covered there. So what we'll do, I'll provide you the recorded lecture for it. The YouTube video link will be there, so you can watch that video. Not every video you cannot watch. Obviously, that's not possible. But at least you can watch selected topics video like Gauss theorem from chapter number 1, or you can watch the videos regarding, if we talk about electric potential and capacitance, then you can see the circuits of capacitors. So such small topics can become important for you before we move on to other topics. But if we start from chapter number 1, in this batch, if we start freshly from chapter number 1, so you people also know the condition of the syllabus right now. Many in your schools right now, most of you have completed with chapter number 4. Many of you will start with chapter number 5. And in your class, like Mithun, you told 5 chapters are also over. Aman, what about you?
We will start we just started chapter number 4 before the summer vacation.
Before the vacation. So chapter 3 you had completed already. Yes. So see, yes, all of you can notice these things that you people are mostly around chapter 4, 5, 6 in your schools. So if we just start from the lesson 1, from the very beginning of the class, that electric charge topics, so we won't be able to finish off the syllabus. So at least what we can do for chapter number 1 and chapter number 2, we can see we can watch those video lectures. I'll provide you the link, or I'll get you people added on the WhatsApp group. On WhatsApp, I'll provide you the link for the video. So anytime that is mutually decided, duration I'll provide you, like from Monday to Wednesday, whenever you get time, watch the video. Not every topic, only specific topic which are very important. And there, if you people are having any difficulties, any question that has been discussed in the class and you're not able to understand any topic, any portion that didn't clear, you are free to ask. We can arrange a class on a specific topic if you want. Doubt class can be arranged for it. So as per your wish, we can arrange with that. So few students had this class of electric current. It was a very short class of electric current we had. So basic introductory part was introduced. Right now, I'll be just revising all these terms, and we'll be still today, we just have 1 hour today. So we'll be continuing this only. So regarding chapter number 3, electric current electricity. Remember, when you are dealing with unit 1, in unit 1, your unit 1 is electrostatics. So electrostatic comprises of your electric charges and field, and the chapter number 2 of NCERT part 1 is your electric potential and capacitance. There your charges are at rest. Charges are at rest means you don't talk about the terms like velocity, you don't use the terms like acceleration for a charge. A charge at rest means velocity is 0, the charge is not in motion. So in electrostatics, we deal with charges which are at rest. Current electricity is that branch of physics where the charges begin in motion, where we can or we are allowed to use the terms like velocity of a charge, acceleration of a charge. Then how these moving charges produce magnetic field, that will be dealt in your chapter number 4. From your chapter number 4 onwards, the introduction of magnetism gets involved. So basically your book 1 of your book 1, that is part 1 of NCERT, that deals with electromagnetism. So in electromagnetism, one portion is completely electrostatics and current electricity, and the last portion is magnetism. So right now let's start with the current electricity, which is your electric current is the basic topic for it. Otherwise, in electromagnetism, the very, very basic topic is electric charge. So I think from this batch, I had a class with Mariam. Mariam, we had a class on electric charge, no? Mariam?
Yes, ma'am.
Yes, we had a class on electric charge. So since we are a deficit of time, definitely we cannot discuss electric charge in detail, but in short, electric charge is a very basic or intrinsic property of matter. It gives rise to various phenomena which you people must have heard of: electric forces, electric fields, Coulomb's law, and all. So many laws you people have heard. So electric charge is a very basic quantity, and it's a fundamental quantity. When you were in class 11th, I don't know who from all of you who remembers this, but you might have classified physical quantities as fundamental quantities, as derived quantities. In case of charge or your current, these are fundamental quantities. With the help of these, you derive other quantities. Regarding electric current, basically, electric current is the rate of flow of charges. Means whenever anything gets divided by time, changes with respect to time, we call it as rate. We use the term rate. All of you must have studied velocity. All of you must have studied acceleration in your 11th standard. All of you must have done that. Do you people remember the formula of velocity? Velocity was what? Velocity was basically rate of change of displacement. So why did we use the term rate? Why not anything else? Why not gradient, or why not something else? Because displacement got divided by time and displacement changed with respect to time. So we use the term rate of change of displacement for velocity. Similarly, velocity getting divided by time gave you acceleration. So acceleration was what? It was rate of change of velocity. So again we use the term rate. Similarly, in case of your current electricity, when we talk specifically about electric current, it is the rate of flow of charges. Like if I take this wire, if I take this basic wire, all right, this is a normal simple wire that you people deal with it. Most of you be using these in your earphones, like this wire is connected in the headphones. So normal simple wires. Now if I take this very small section of a wire, very small section, this portion I've taken, I have just drawn this broadly in this way. So I start at t is equal to 0, I start the timer. And exactly at t is equal to 1 second, no, I stop the timer back. So at t is equal to 1 second, when I stop the timer, what do I see? I see some q amount of charges have flown through the wire. So basically, this charge, the amount of charge that has flown through this wire, again, I'm telling you, this is not a very thick wire or a cylinder something. It's normal, simple, thin cylindrical wires like this. So don't get confused with the diagram. We just have to enlarge and write it because we have to understand things. So rate of flow of charges basically means this only. In 1 second's duration, what was the amount of charges that flowed through the wire? That we call it as electric current. So electric current is a very common term. All of you must be using the term current. So you have to, now in class 12th in current electricity, you have to focus on the formula, on the mechanism of current, correlation of current, the velocity of current, the velocity of electrons, because basically these electrons only flow inside a conductor that make the flow of charge occur. So the formula of current becomes simply charge per unit time. And if you put in this formula as t as 1 second, if you put this time period as 1 second, you can easily see I becomes equal to q. As soon as I put the time as 1 second, I am able to observe that current is equal to the charge. So a new definition, the third definition, first definition was rate of flow of charges. Second definition was charge per unit time. And the third and the most important definition for an electric current becomes that it's the amount of charge that flows for a duration of 1 second. Because you can see current is directly equal to the charge here. But the condition that is hidden beside is that the time duration is 1 second. So current is the charge that flows through a conductor or a wire or any device for the duration of 1 second. Clear? Now, SI unit of charge is amperes. Mithun, can you tell me what's the SI unit of electric charge?
Coulombs.
Coulombs, perfect. So basically we write 1 coulomb by 1 second as 1 ampere. 1 coulomb per 1 second. And I just suggest you, Mithun, just from the next class onwards, just try to enter with your name, whatever is your name, official name, with that. Fine?
Okay, ma'am.
So this is 1 ampere. 1 ampere is the SI unit of electric current. You might have heard of these terms, 4 ampere current flow or 5 ampere. So ampere is basically the SI. Now, regarding whether it's a scalar type of quantity, whether it's a vector type of quantity, so that is definitely fixed that it's a scalar type of quantity. There is no doubt in it. But why do we consider it as a scalar type of quantity? Aman, do you remember? I had discussed it with you, I believe, no?
I'm sorry, ma'am?
Do you remember why we consider electric current as scalar and not
yes.
as vector? Yes, try.
Because it doesn't follow the vector rules, the vector laws.
Perfect. Yes, right. See, all of you, electric current has a direction. There is a direction of electric current. Basically, if we just recall our basics from class 11th, we have seen what? Physical quantities can be divided as vector quantities as well as scalar quantities. Scalar quantities are those which just have the magnitude. Like you people might have heard of the term potential, electric potential. You must have done it in your chapter number 2. We'll also discuss it once. So potential is a scalar quantity. It does not need any direction to be specified. You just write the magnitude using the different formulas you have. Vector quantities are those quantities that have a magnitude as well as a specific direction. Like if I choose plus direction for right hand side, I choose right hand side as positive and my velocity is coming as minus 5 meter per second. So I'll say definitely the direction of velocity is left hand side. That's why a minus sign has been added. So vector quantities have a magnitude as well as a direction associated with them, with that magnitude, apart from the SI unit. SI unit are there in the vector quantities or scalar quantities. SI unit is not concerned with the scalar or vector forms of quantities. But regarding electric current, we see that electric current has a direction. Direction is what? Let's just discuss the direction. See, for a positive charge, if there is a positive charge, like this is a positive charge, and this is the direction of motion of the charge, means the charge is moving towards the right hand side. This is the motion of this charge. So the electric current that is developed in the charge, whenever the electric current will be developed, for a positive charge, it will be in the same direction as that of the motion of the charge. If the charge is moving upwards and it's a positive charge, then the direction of current becomes upwards only. If the charge is moving towards the left, and it's what? And it's a positively charged. Positive charge is moving leftwards. So the direction of flow of current, that also becomes leftwards. Whatever is the direction of for a positive charge, just exactly same as the direction of the electric current. Regarding the negative charges, because this point becomes important, because we mainly have to deal with electrons, entities like electrons. Most of your current electricity portion includes your electron. Who remembers the electronic charge? Anyone from the class? What's the electronic charge? Charge on a single electron.
1.6 into 10 raised to
10 raised to
minus 19.
minus 19. Exactly. Good. So electronic charge is basically 1.6 into 10 to the power minus 19 coulomb. One more thing, this value will not only be utilized in this lesson, first, second, third. This value of electronic charge will be utilized till your semiconductors lesson. Semiconductor is the last lesson of your syllabus. So until semiconductors, this value will be utilized. So I will suggest all of you to remember at least this value. Others value will be provided to you in the question or the numerical itself. Fine. So for a negative charge like electron, you have to reverse the direction of current wherever is the charge moving. For example, let's say the charge is moving towards north and the charge is negative, then your current will flow towards south. Exactly 180 degrees opposite. Just make it opposite. So this is the direction of the electric charge. But if it has a magnitude, we are considering electric charge has a magnitude that is 5 ampere, 4 ampere, 3 ampere, any value. And we are also specifying the direction for a positive and negative charge. But apart from these two important points, we are also considering it as a scalar quantity. So as rightly answered by Amin, these electric current do not obey the vector laws. You might have studied and heard of those laws, vector laws, which are parallelogram law, which are those triangle law, polygon law, all these laws are there. So those laws are not obeyed by electric current. And this is a major condition for any physical quantity to be called as a vector quantity. And this is not satisfied by electric current. That's why we do not consider electric current under the category of vector quantities. We consider it as a scalar quantity. First, tell me all of you, is this clear to all of you? Maria?
Yes, ma'am.
All right. Amin, I hope it's not becoming boring for you because we
No,
had
ma'am.
an
Not at all.
introductory class for it. No, just have patience for today's class because other students have the
I
stock.
actually have to leave in 5 minutes. Is that okay?
Okay, for sure. So
Okay. Thank you.
fine, that's okay. Because you had this class, so you won't miss some things. But just remember, one thing I'll suggest to all of you to follow the video lectures. Whenever I send you the video lecture, I'll get you people added on the group. So I hope that's not an issue for any of you. Or any other suggestion? Any other suggestion is welcome. Fine, by all of you. Whatever you want regarding the backup classes.
Okay, ma'am.
All right. So do one thing, rest of you just note down all these points.
Excuse me, ma'am.
Yes, Nathan, say.
Ma'am, regarding this electric current, it does have a direction and the magnitude, but since
Yes,
it's not following the vector law, only because of that, it is considered as
it is
a
considered.
scalar quantity.
Yes, yes. Because if you have two directions of electric current, no, you never apply any parallelogram law and check the angle between them. If you have the magnetic field with you, magnetic field is a vector quantity. So when we will come in chapter 4, we will see that magnetic fields are using those vector quantities. If they are making an angle of 90 degree, they are following the parallelograms law. But this is one of the major conditions for any quantity to be categorized either as vector or scalar. So that's why we are not allowed to consider it as a vector quantity. And also, Mithun, remember one thing, electric current is the only quantity. This is a very nice question, you can say. This is the only quantity which is categorized under scalar quantities. No other quantity is there who has a direction as well as a magnitude and is considered as scalar. So this can be a good question for your knowledge, especially for people who will be appearing after their class 12th for their entrances like JEE, NEET and all these. So these little questions can come in the exam.
Okay, ma'am.
Just text me done in the chat box when all of you have written so that we can move forward. All right, so all three of you have written. Fine. Now see, we'll see because it's your first class today with me, so I'm going very slow in this class. From the next class onward, we'll speed a bit. See, regarding electric currents formula, no, that we have studied, I is equal to Q by T. This is not as simple as it seems. Means you cannot just have the value of charge and the value of time and you divide it and you get your answers in the exam. The questions in the exam do not come so simple that you will get the value of charge as 2 coulomb, you will get the times value as 2 seconds, and you get the current as 1 ampere. This small topic will be utilized in the circuit. But when you have a specific question on electric current, this I is equal to Q divided by T. So basically what happens, we have to consider what kind of formula are we going to use. For example, there are two types of times that are given to you. Time value, T is equal to 1 second, T is equal to 2 seconds, or any other value, that time. It can be either a time interval or it can be a time instant. Two quantities can be given to you in the examination. Now let's discuss both of these. We'll do question also on this in today's class only. We'll see how do questions actually come in the exam from this topic. I is equal to Q by T. Time interval means, for example, for me at my time, IST time, the class started at 7. And supposedly, let's say the class ended at 8 p.m. So time interval for me becomes 1 hour, that is 7 to 8 p.m. For me, it becomes 7 to 8 p.m. Time interval for you people is also 1 hour if you subtract. So that we call as a time interval when the time has a beginning and time has an ending. Fine, that is 0 to 2 seconds. For example, I have taken the example over here. But when I give you the time, like let's say, for example, it's exactly 7:25 p.m. right now over here at my place. So I'll say, what am I teaching exactly at 7:25 p.m.? So that is not an interval, no, or not a duration. That is exactly a moment, a time instant we call. Like, tell me the current that is flowing through a wire in at exactly t is equal to 2 seconds. That becomes your time instant. So there's a difference between time interval and there's a difference between time instant, and either of these quantities can be provided to you in the examination. Now see, when you have the time interval with you, like t is equal to 0 to 2 seconds and any interval like this, like 7 to 8 p.m., 3 to 4 hours, any time interval which you people can easily identify at this age. The type of current that you get, it is known as an average current. In case of average current, you basically find out the difference in the charge. That is Q final minus Q initial divided by time final minus time initial. Means whatever is the change in the charge divided by change in time, that you call it as the average current, and you get it in the case of time interval. Now how to solve it, how to use it, how to apply it, that we'll see right now. I'll tell you how to do that. Time instant, when you have the time instant, a specific time instant is there, then you have to basically differentiate the charge. Differentiate the charge with respect to time, dq over dt, with respect to the time, differentiate it. So I is equal to dq over dt, and the kind of current that you get, that is known as an instantaneous current. So this won't get clear just by looking at the formula and the theory portion. Do one thing, note these 2 points and let's do a question on it. Question has been pre-written for you people. So just note it. At least note the above portion first and we'll discuss it. Have you others also written? Only Pavitra, are you understanding?
Yes, ma'am.
Okay, Mariam has also written. And what about Mithun? Written the above portion, that yellow portion, the theory part.
Yeah. Or
Let's just discuss this, how to use it. See, it has given you an equation of charge. This way of the question will come in the examination. Either it's your 12th board class examination, or even it's your entrance examination that you have to appear for various universities and other entrances after class 12. This way the question comes. You have the value of time interval or time instant that you have to identify, and accordingly you have to perform, whether you have to calculate the average current or you have to calculate the instantaneous current. So equation of charge has been given to us that says 3t square plus 2t plus 1, this much coulombs. We have to calculate the current in t is equal to 0 to 2 seconds. So Pavitra, can you tell me, is this a time interval or a time instant? First part.
Interval.
Interval, perfect. That's a time interval from 0 seconds to 2 seconds. This becomes a time interval. In the second part, you have exactly to find out the current at t is equal to 2 seconds. So exactly at t is equal to 2 seconds. So that becomes what? That becomes your time instant. So for the first part, what did we discuss? For the first part, we have to find out the average current. Average current was delta Q divided by delta T. So final time is what? Final time is 2 seconds. So Q final will be what? Just put 2 seconds everywhere instead of T. So here it becomes 3 into 2T square plus this 2. Then again 2 over here because of this T plus 1. Fine, because I have to find out the value of charge from 0 to 2 seconds. So I'll count the final value of charge because I have to subtract it from the initial value so as to get the change. This becomes what? 4 into 3, this becomes 12. 12 plus 4 becomes 16 plus 1 becomes 17 coulombs. This is what? This is the final charge. Now, initial charge, this Q initial means t is equal to 0 seconds. So let me put 0 everywhere where I have t. So this becomes 3 into 0 seconds. Instead of t, I'm writing 0 everywhere. Plus 2 into 0 plus 1. So all these terms become 0, only 1 is left with us. Final time is what? Final time is 2 seconds. Initial time is given as 0 seconds. So current will be what? See, change in charge means Q final minus Q initial divided by change in time, that is T final minus T initial. So final charge is 17, initial charge is minus 1. T final is 2 minus initial time is 0. That becomes 16 divided by 2, which is 8 amperes. So 8 ampere is the average current that I'm getting. Second part says what? Your second part says current at t is equal to 1 seconds. If any one of you is having difficulty, you can either unmute yourself, and if you are hesitating to ask, you can type your answer or your query in the chat box. I'll read it and I'll answer your doubt if you people have any doubts. Or you can simply unmute yourself. That's the best thing. So Q is 3t square. Now we have to differentiate it. Are you people clear with differentiation? Yes or no?
Yes.
yes, ma'am.
Yeah, and Mariam? Mariam? Here or some difficulties? It's clear. All. So if it's clear for all of you, then that's very good. Even if you people have difficulties, we can have a class on calculus where we can study the basics of differentiation and integration. We have these classes. So wherever you have doubts, we can have these classes on calculus, integration, differentiation, basic vectors that we can discuss. So this is 3t square plus 2t plus 1. Now I have to differentiate it. I is equal to dq over dt. So 3t square. 3 is a constant term. Differentiation of t square. Mithun, can you try this? I'll help you. Can you try? What will be the differentiation of this? 3t square.
Ma'am, 2t, is it?
2t. Yes, yes, perfect. That becomes 2. So 3 will be there. It's a constant term. See, for all those who have forgotten, and if you people even remember it, I'm just recalling, x to the power n, when you differentiate, this becomes nx to the power n minus 1. So here your n was 2 and this became 2 minus 1. Basically, it's like t square became 2t to the power 2 minus 1. That is 2t. So perfectly answered, this is 3 into 2t plus. Mariam, can you try this? 2t1. How to differentiate this? What will be the answer when we differentiate it? Any idea, Mariam? Exactly. I'll help you with it. Anyone else who can try 2t?
2,
Yes, Pavitra? Your voice is very low. Can you repeat?
2,
2. Perfect. See, Mariam and others also see. 2 is the constant term. What are we left with? We are left with t only. That means t to the power 1. What did I tell you? N will come out. So here your n is 1. So this becomes 1 into t to the power 1 is left. You have to subtract 1 from your power of n. So that becomes 1 minus 1. T to the power 0. Any constant term or any variable term raised to the power 0 becomes 1. So this is basically 2 into 1. That is 2. Mariam, did it get clear or should I repeat this 2t part? I'll repeat. See. See, whenever you differentiate x to the power n, n means the power. So here your term is t. So t has the power 1. So x, instead of x, we have the variable t. Instead of number n, power n, we have the power 1. When we differentiate it, when we perform differentiation in this, n comes out. So here t is to the power 1, so 1 will come out. What is left now? X to the power n is left, means 1 into t to the power 1 is left. Whatever term is now left, no, just subtract 1 from the power. So t to the power 1, if I subtract 1 from the power, that becomes 1 minus 1. So this is what? This is basically t to the power 0. Any quantity, any variable, or any constant that is raised to the power 0, that we write it as 1. That has no significance. It is just written equivalent to number 1. So here what did we have? We had 2 written over here. 2 was the constant. Whenever we are performing differentiation or integration, whatever is the constant term, that gets separated. It comes out and gets multiplied. So 2 got multiplied the way 3 got multiplied over here. So t to the power 1 minus 1 becomes 0, becomes 1. So we have only 2 left. And when we differentiate a constant term, we get 0. Now tell me, is this clear? With some other term and explain. Yes, I can. I'll explain you with some other term. Instead of t to the power 1, let's take some other value. Let's say y cube. I have to differentiate y cube. So others who know the answer, just try this. 3y cube, let's take. All of you, others, Pavitra and Mithun, you people try. Or if you are having doubts, you can also listen. See, Mariam, the constant term 3y cube, the constant term in here is 3, the number 3. So 3 is written separately. Or in order to distinguish between both the 3, let me just make it some other number. Just Our example is 5y cube. This is the example we are differentiating. Fine. Now, in this example, 5 is a constant term and this is a function of y. Constant term gets separated and gets multiplied. So 5 is the constant, we will separate it. Now we just have to focus on y cube. This is our focus. So x to the power n, you have y to the power cube. So Mariam, you only tell me, what is n in this example? From this, you can compare 3. Perfect. So n comes out and gets multiplied. It means, as rightly said by you, 3 is n here. So 3 will come and get multiplied by this term, that is y cube. Fine. These are getting multiplied. Now, we don't leave our answers at this step. Whatever is the power now left, no, just subtract 1 from here. So what do we get? 5 into 3 becomes 15. Here we have y, 3 minus 1 becomes 2. So differentiating 5y cube gives 15y square. Now is it clear? We'll do more questions on it as soon as they will come. We'll be discussing it. But first tell me. And others also, is this clear?
Yes, ma'am.
Here? All right. So similarly, that's why we have written this 2 over here, and differentiating a constant term always gives you 0. Even if you are integrating a constant term, you get it as 0. So what's the equation now left? Your final equation left from here, it's 60 plus 2. What's the time exactly where you have to calculate the current? That is t is equal to 2 seconds. So put in the value of 2. Here at t is equal to 2 seconds, if you put the value of 2, your current becomes 14 amperes. So you can see your average current was coming 8 amperes in the first part, and the second part, your instantaneous current is coming 14 amperes. 14 amperes is the current exactly at t is equal to 2 seconds. And during this duration, 0 to 2 seconds, your current is 8 amperes. All of you note down this question. If any doubts you people are having, tell me. We'll do more questions on this current. Not this kind of question, a different question that comes in your exam. If it's 7z square, so that becomes 7 into 2 to the z into to the power 1. So it will be 14z. Perfect. Yes. Yes, Mariam. It will be 14z like this. So all of you have written it, or anyone is writing? Just let me know so that we can move on to the next question. Done? Done the writing portion,
ma'am.
others? And what about you both? Yes. Let's do one more question that does not involve your numerical values, but these kinds of question also come in your examination. It says that an electron is revolving around with the frequency nu. This symbol is known as nu, and you must have used this symbol. So this electron revolves around the nucleus with this frequency nu. This frequency nu and all these combinations, frequency and all, will come back in your modern physics when we'll study. You might have used all these terms when you were in class 11th in your quantum physics that came in your chemistry portion. So these topics are there in detail, but right now we don't have to focus so much on it. This stage, you should know the relation between frequency and time period. Can anyone tell me the relation between time period and frequency? Anyone has an idea?
Reciprocal, like frequency is equal to 1 by
Yes.
time period.
Exactly. Frequency is basically reciprocal of time period. Time period can be written as 1 by frequency, or frequency can be written as 1 by time period. This is a relation that you should know. Questions can be related because time period gets utilized in case of current. So you should be aware of all the relations that are related with time period. Now it says to calculate the current. For all those, we didn't have a class on the properties of electric charges because of deficiency of time. Frequency, yes, time period. Frequency is the reciprocal of time period. We also have the reciprocal SI unit. Like for time period, it's second, Mariam. So for frequency, it's hertz or it's second inverse because it's just reciprocal of it. So this formula is valid. You can use it anywhere. Now, in this, we have not discussed that, but you might have asked this. Mithun only answered that the electronic charge is 1.6 into 10 to the power minus 19 coulomb. So charges basically are integral multiple of this number. Like a single electron will have the value 1 into electronic charge. If 2 electrons are present, they have the value 2 into this electronic charge value. if 3 electrons are present, so they have the value 3 into 1.6 into 10 to the power minus 19. That becomes 3 into E. Then you have 4 into E, 5 into E, and so on. It will go on increasing. So basically, its charge will be n times E. You can generalize it if n is the number of charge. N can be 1 for a single electron. 2 electrons present, n can be equal to 2. 3 electrons present, n can be equal to 3. Such values you people can have. Q is equal to Ne. Now, I think you people must have heard of this. This is basically known as quantization of charge. I'll write it down. Charges have few properties like additive nature. So one of their properties is quantization. Quantization of charge means basically they are integral multiple of this number. If 1 electron is there, then it has the charge 1.6 into 10 to the power minus 19 coulomb. 100 electrons are there, that become 100 times the C. This is known as E. So that's why Q is equal to N. So we have the value of Q, we have the value of time. What is the formula of current? Current's formula is basically charge divided by time, the general formula of current that we use. So current is basically charge divided by time. What is the value of charge for a single electron? Why are we writing Q is equal to Ne? Because the quantity electron has been mentioned to you, that they are talking, the question has been mentioning about an electron. So you have to apply all the properties of electron. So for an electron, the charge is what? Charge is basically Q is equal to Ne. So if I put all these formula in this equation, both these, instead of charge, I can write as Ne. Instead of 1 by time period, I can write it as frequency. This becomes the formula. Here, why am I writing like this? Because charge is Ne. What is left? 1 by time period is left. This is 1 by T. And 1 by T can be written as frequency. So I is equal to Ne. All right, note down this as well. And text me done when all three of you have written it. In the chat box, you can text. If any queries are there, any doubts you people are having, you can ask me. So on Monday, you people are having your vacations, no, right now? When are your schools opening?
Ma'am, for me by September 1st.
October 1st or
September 1st.
September. Okay, September 1st. And what about others, Pavitra?
For me, it is August 2nd.
August 2nd. So your vacations are almost on the end, Pavitra, no? 5th September for you, Marin. Fine. So it's 5th September. So most probably this is the last portion of your vacations. Fine. So I can it's today, it's 23, no? So let me send you the link on Monday for the first video lecture. So till the time we meet, you people can, I'll send you 2 lectures till the next class we have. Means till next Saturday, I'll send you 2 videos. Whenever you people get time, you can watch it. And you can ask me the doubts. Or you can even arrange for a class with me. On WhatsApp, I'll connect you people on the group. There's a WhatsApp group where all the class 12 students are there. So I'll connect you on the group.